Due to the acceleration or the motion of electric charges, electric current will produce. Any device which obeys Ohm's law in its functioning, we'll call them as ohmic device. The best example for ohmic device is a resistor. What is resistance according to Ohm's law? It is given by R is equal to V by I. So this is the resistance of the slab. Decreasing the area of cross section of the conductor doubles the resistance. Hello everyone, welcome to session 1 of chapter 3 Current Electricity. This is Swati from Department of Physics, Vidhyaashram University College, the Temple of Excellence, Mysuru. Dear children, in the first two chapters, that is electric fields and charges and electrostatic potential and capacitance, we have studied about the charges in its static condition. So that is static electricity, which means the study of charges when they are at rest. So in this chapter, we are going to study about the flow of charges, the study of charges when they are in motion, and that is current electricity. So the study of charges when they are in motion constitutes electric current, and we are going to study more about these concepts in a chapter called current electricity. So this is the basic difference between the static electricity and the current electricity. So let us learn more about current electricity, which means the study of charges when they are in motion. We know that when charges are in motion, they constitutes electric current. So what do we call if the charges are in uniform motion? In conductors, electrons are the charge carriers, as we all know. So electrons will accelerate due to the electric field and they constitute an electric current. Due to the acceleration or the motion of electric charges, electric current will produce. Now, if these charges are in uniform motion, we call it as steady motion. So, we'll call it as steady current. Steady current means the continuous current. If to maintain the steady current in a conductor, we must take care of the uniform flow of charges. So this is the basic concept of electric charges and how the electricity or the electric current will produce. So now let us learn about electric current. How do we define electric current? So you can just remember this expression. Electric current or current is denoted by the letter I. It is nothing but the flow of charges, that is Q, it is given by Q. The flow of charges through any cross-sectional area of a conductor is steady. Then the electric current is defined as the ratio of total charge flowing through the cross-sectional area in a given time, which means I is equal to Q divided by T. I is electric current, Q is the total charges flowing through the cross-sectional area, T is the time taken for the charges to move in a conductor. So now, according to quantization rule, we know Q is equal to N into E. So we can substitute NE divided by T, and this is electric current. What is the SI unit of electric current? It is ampere, which is given by capital letter A. Now, is a current a scalar or a vector? Though it has a magnitude and a direction, the current is said to be a scalar quantity because though it has both the magnitude and direction, it do not follows the laws of vector addition, but it follows the laws of scalar addition. And it also doesn't depends on the angle between the wires, which means the angle will not affect the total current flowing in a circuit, and hence we will conclude it, and hence we say current is a scalar quantity. So these are the basic concepts regarding electric current. Let us now study one of the important law which relates between the voltage, that is the potential, current and resistance, which is given by Ohm's law, which is very important examination point of view. So what is the statement of Ohm's law? It says, I told you already, it is the relation between current, potential and resistance. So it says that the electric current which is given by I through a conductor, which is directly proportional to the potential difference, that is V. I is directly proportional to V across the ends of the conductor, provided the temperature and the other physical conditions remains constant. So in general, in a easy way, we can remember Ohm's law as I is directly proportional to V. the current and the potential across the ends of the conductor are directly proportional to each other. Now, this can also be written as V is equal to I into R, where R is nothing but the resistance. So, the Ohm's law gives us the relation between potential, current and resistance. V is equal to IR, that gives the relation for how the potential is dependent on current as well as resistance. So, from that expression we can even write I is equal to V divided by R. What is the SI unit of resistance? The SI unit of resistance is ohm, and symbolically it is given by this symbol. So, ohm is written as this. Ohm is the SI unit for resistance. So, in this above expression, I is equal to V by R. I is the current, V is the potential difference and R is the resistance of conductor. What is the reciprocal of this resistance? It is conductance. Before studying about conductance, let us understand what is the meaning of resistance. So, resistance is nothing but the opposition offered by the conductor to the flow of charges or to the flow of current, and it is also defined as the ratio of potential difference across its ends to the current flowing through it. From Ohm's law, we know V is equal to IR, and from this we can write R is equal to V divided by I. So, resistance is basically the opposition offered to the flow of charges in any circuit. It can also be defined as the ratio of potential difference, that is V, to the current flowing through it, current flowing through the conductor. So, this is resistance. What is the circuit symbol of resistance? We use resistors in any circuits, right? So, how to write the circuit symbol for a resistance? It is given by this. The circuit symbol for resistance is the crisscross form of a wire. Now, from this, can we define 1 ohm? The unit of resistance is ohm. How to define this 1 ohm? We know when these two quantities on the RHS becomes 1, then we can define resistance as 1 ohm. So, this is the simplest way to remember the definition for 1 ohm. So, let us now define it. So, the resistance of a conductor is said to be 1 ohm if a current of 1 ampere flows through the conductor when the potential difference of 1 volt applied across its ends, which means the potential becomes 1 volt and the current flowing through the conductor is 1 ampere. Then V divided by I we have in the RHS, that is 1 divided by 1, which will give us the value 1. So, the resistance is said to be 1 ohm. Now, what are the devices which obeys this Ohm's law? So, we will call it as ohmic devices. So, any device which obeys Ohm's law in its functioning, we'll call them as ohmic device. The best example for ohmic device is a resistor. So, resistors are used in the circuits to oppose the flow of charges so that the excess charges flow can be avoided with the help of resistances, so that we can even avoid damaging the circuits. So, resistors are the best examples for ohmic devices. And these are the resistors. You can have a look at this. And what are the devices which do not obey Ohm's law? And the devices that does not obey the Ohm's law are called as non-ohmic devices. What are the examples for non-ohmic devices? The examples for non-ohmic devices are semiconductors and transistors. They do not obey Ohm's law. And about these semiconductors and transistors, we are going to discuss in the upcoming chapters. Now, in this chapters, we will discuss about resistors and resistance. Now, we know what is the meaning of resistance. It is nothing but the opposition offered to the flow of charges. How does this resistance depends on length of a conductor? Let us now understand. So, I have considered a conductor of length L. So, here V be the potential difference applied across the slab, and the flow of charges are there in the conductor, which means it constitutes an electric current. So, I be the current through the conductor. Now, what is resistance according to Ohm's law? It is given by R is equal to V by I. So, this is the resistance of the slab. So, I have now increased the length. Now, I have increased the length twice of its original length. You can see here length. This is the original length. Now, I have increased the length of a conductor. So, now the potential difference across the ends of this conductor becomes 2V. Initially, it was only V. Now, the Ohm's law says that resistance is equal to V divided by I. Since the potential doubles as we increase the length, it is 2V divided by I. Now what is V by I? V by I is nothing but resistance. So I can write it as 2 into R, which means that the new resistance of a conductor when its length increased is 2 times its original resistance, which means we can conclude that the resistance of a conductor is directly proportional to the length of it, which means as we increase the length, the resistance will also increase. Now let us understand how does this resistance depends on area of any conductor. So initially the area of the conductor was like this. Now we have divided this area into 2 parts, which means I have halved the area. A divided by 2 says that it is half of its initial area and L be the length of the conductor. So I have considered the combination of 2 identical slabs whose length is L having a cross-sectional area A divided by 2, which means the area becomes lesser than the previous condition what we have studied. When the same potential difference V is applied across, then what happens to the current? It will also decrease, right? So the current through the each slab becomes I divided by 2. Then the resistance of each slab is given by, according to Ohm's law, it is R is equal to V divided by I. Now the potential is same for both the slabs. I becomes half. So our new resistance will become V divided by I by 2. Now from this we can write 2V divided by I. What is V by I? It is R. So it becomes 2R, which means decreasing the area of cross section of the conductor doubles the resistance. As the area of the conductor decreases, resistance will again increase. So from the first condition and the second condition, resistance of a conductor is directly proportional to L, which means as we increase the length, resistance will increase and it is inversely proportional to area, which means as we decrease the area, resistance will increase. So this is the condition or the dependence of resistance on length and area of a conductor. Now let us understand what are the factors on which the resistance of a conductor depends on. We know it depends on the material of a conductor because the resistance or the flow of charges or the action of charges depends completely on the nature of material, and also it depends on the length and area of cross section of a material or of a conductor, and it also depends on temperature. From the previous 2 scenarios, we came to know that resistance is directly proportional to length and inversely proportional to area. Now, this proportionality can be replaced by a constant, and that is rho, where rho in this case is the resistivity of a material of a slab. So, resistivity is given by rho. Now, what is electrical conductance? So far, we have studied about the resistance. Now, let us understand what is electrical conductance. Electrical conductance is given by a letter G. So, it is nothing but the reciprocal of resistance of a conductor. So, the resistance, we know what is the meaning of resistance. When you take the reciprocal of resistance, that is G is equal to 1 divided by R, where G is conductance. What is the unit for conductance? It is mho, or we can even call it as Simon. So, the symbolical representation of mho is given like this. Now, let us define what is resistivity. We know resistance is equal to rho L divided by A. When L is equal to 1 meter and A is equal to 1 meter square, then R is equal to rho, which means the resistance offered by a conductor of unit length and unit cross-sectional area is nothing but resistivity. What is the SI unit of resistivity? It is ohm meter. Because we know the resistivity from this expression, resistivity is given by R A divided by L, because this will get multiplied with R. Then rho is equal to, what is the unit of resistance? It is ohm, area unit is meter square and length is meter. So now 1 m and 1 m will get cancelled and we remain with ohm meter, and that is the SI unit of resistivity. How do you define electrical conductivity now? Before that, in the previous slide, we have defined conductance. Now, we are defining electrical conductivity. So, electrical conductivity is the reciprocal of resistivity. So, reciprocal of resistivity is electrical conductivity, and the SI unit of electrical conductivity is mho per meter. So, these are some important basics regarding the concept called current electricity. In the upcoming sessions, let us learn some more interesting concepts. Keep learning, all of you. See you all in the next session. Thank you.